Okay, so how to graph a rational function. So there's several things that we can look for here to help us graph it. And so the first thing they tell us is we're going to find the domain, then we're going to find our vertical asymptotes and our horizontal asymptotes. We're going to determine if the graph crosses a horizontal asymptote by setting the function equal to the horizontal asymptote. We're going to find the Y-intercept if there is one. We're going to find the X-intercepts if there are any. We're going to plot at least one point between and beyond each X-intercept and vertical asymptote. We're going to determine whether the graph has symmetry, and we're going to use the information obtained previously to graph the function between and beyond the vertical asymptotes. Okay, so let's look at number 11. It says us to graph each rational function. And so we're going to go through and do all the little things that it told me to do. So the first thing it said is to find the domain. So remember your domain, because this is a fraction, your domain is where your denominator cannot equal 0. So x minus 1 cannot equal 0, which means x cannot equal 1. So my domain is from -infinity to 1 and 1 to infinity. Then it tells me to go ahead and find my vertical asymptotes. And I like doing that right after the domain anyways because they're very closely related. So really though, we need to put on there, and I should have did it when I was up there, but where it says number 2, find any vertical asymptotes, go ahead and put and holes, because if there's a hole in the graph, we need to find it as well. So for this one, I can look at it and let's see, let me find my holes first. So I'm looking at my problem, it's totally factored out, I can't factor it out anymore, and nothing cancels, therefore there's no holes. And I need to find my vertical asymptotes. Well, so that means that x minus 1, where it's equal to 0, is my vertical asymptote, which means I have one at positive 1. So x equals 1 will be my vertical asymptote. Alright, number 3 tells me to find any horizontal asymptotes. So I'm going to look at my function, and I notice that here that my largest exponent on the top is x to the first, and the largest one on bottom is x to the first. So this is where we're going to use that y equals a over b. So for horizontal asymptote, ours is going to be y equals a over b. And remember, a and b are their coefficients. So the coefficient of the top one is 3, and the coefficient of the bottom one is not written, so it's a 1. So it's going to be 3 over 1, and so my horizontal asymptote is going to be at y equals 3. Okay, so step 4 tells us to determine if the graph crosses a horizontal asymptote by setting our function equal to the horizontal asymptote. So we want to know if it's going to cross in that middle somewhere. So what we do is we set our function, which let me go ahead and erase where I circled up there. So we're going to set our function equal to our horizontal asymptote, which is 3. So we have 3x over x minus 1 equals 3. And we're going to solve for x. If I can get x equals a number, it will cross at that x value. If I can't get x equals a number, then that means it's not going to cross it. So I want to get rid of this fraction, so I'm going to multiply by x minus 1. And what you do to one side, you have to do to the other. And so we end up with 3x equals, I'm going to distribute over here, so I get 3x minus 3. And I can see that these 3x's will cancel, so I end up with 0 equals negative 3. Because I did not get x equals a number, it will not cross. Alright, so we're on number 5. Number 5 is our, what is number 5? Oh, Y-intercepts. So how do you find the Y-intercept? Well, you plug in x is equal to 0. So I'm going to have to do that up here at the top. So let's see, Y-intercept, that's where x equals 0. So my function is y equals 3x over x minus 1. So I'm going to plug in 0. So we get 0 over negative 1, which is 0. Which means I have our Y-intercept. We said when x is 0, and we found when y is 0. Then I'm going to have to find my X-intercepts. And so to find your X-intercepts, that's where you set your function equal to 0. So 3x over x minus 1 equals 0. Just like before, let's multiply by x minus 1. And so we get 3x equals 0 times anything cancels, and therefore x equals 0. Now a little shortcut there, guys, is when we talked about domains, some of y'all had asked me about the numerator, and I told you the numerator has its own job. Well, so I could actually, I'm going to erase this now, I could actually, when I go to do my X-Intercept, I know that that's going to be wherever my numerator is equal to 0. So for my X-Intercept, the shortcut to find that is where the numerator equals 0. So in this case, that would have been where 3x equals 0, which is where x is 0. So for my X-Intercept, I got 0, and we know that the y value, it has to be 0. Alright, so number 7 says to plot at least one point between and beyond each X-Intercept and vertical asymptote. So what I'm going to do right here is I'm going to stop for a second, and I'm going to graph what I already have done here. So first thing I need to do is draw in my x and y axis. And so I'm just going to try to put it here in the middle somewhere. I don't have any really drastic values that are really big or really small, so I don't need to like off-center it. And then I'm going to go through and graph all my pieces. Well, I can't graph the domain, so don't worry about it. We said there were no holes, but we do have a vertical asymptote at x equals 1. So I'm going to go to where x equals 1, and we're going to draw in our asymptotes with dashed lines. Alright, I have a horizontal asymptote at 3, so I'm going to go draw in that up here at 3. Remember, it's an asymptote, so it's going to be a dashed line. We said we had a Y-intercept at 0, 0, and we have an X-intercept at 0, 0. So here's just a quick sketch of what I've got so far. Now, so back on 7, it says plot at least one point in between. Okay, so for number 7, I'm actually going to make a table. Now, different ones teach it different ways. It's kind of like using a number line. So first I'm going to show you the number line to help me create my intervals, and then I'm going to make a table. And this table is going to help me through this lesson and the next one. So it's good that we go ahead and practice it. Alright, so I can see that we're going to use our X-intercepts and our vertical asymptotes. So I have an X-intercept at 0, and I have a vertical asymptote at 1. So my number line starts at -infinity and continues to infinity. So here are my intervals that I'm going to use in this table. So for this table, I set it up. The first column is going to be my interval. The second column is going to be an x value. Then I'm going to get a y value. Oh no, I'm out of room. And then finally, the last thing I'm going to do is the sign. Alright, so good thing we didn't need much room in that last one. So I can already see my intervals. My interval is from, the first one is -infinity to 0. Then we're going to go from 0 to 1. And from 1 to infinity. Now, for our purposes, it really doesn't matter if we use parentheses or brackets, but remember you can never equal a vertical asymptote. So my 1s have to have parentheses, but my 0s can have brackets because we can equal that X-intercept. And that'll make a difference later when we're doing inequalities in 3.6. Alright, so when I pick an X value, I'm going to pick an X value in each interval. Don't be drastic, guys. If you're looking from -infinity to 0, pick close to 0. The smaller in this case, or further away from 0, the number is that you pick, the harder it's going to be when you work it out. So I'm just going to pick like -1. A number between 0 and 1, I'll say 0.5. And from 1 to infinity, I'll pick 2. Now for the y value, I'm going to take those numbers I just picked and I'm going to plug them into my equation there and solve and see what the y value is. So when I go to do the -1, my equation, remember, is y equals 3x over x minus 1. So 3x over x minus 1. So plug -1 in. And so you get -3 over -2, which is positive 3/2. So I'm going to put that it's 3/2 and it's positive. So then plug in your 0.5. So y equals 3 times 0.5 over 0.5 minus 1. So what is that? 1.5 over -0.5. And so we get 3. So negative 3, which is negative. And then I'm going to plug in 2. So I'm going to move over here a little bit. So 3 times negative 2 over negative 2 minus 1. So I get negative 6 over negative 3, which gives me 2. And that is positive. So what I did there is now I've got some other points that I can graph to help me. So I've got that negative 1 and 3/2. I've got 0.5 and negative 3. And I've got 2 and 2. Was that right? 2, 2. Did I mess up? I might have. Let me check that one again. So negative 6 over negative 3. Nope, that should be a positive 2. Alright, so it just looks a little different. Yeah, that one's not working. What did I do wrong? Oh, I plugged in negative 2 and it should be positive 2. Sorry about that. So anyways, it makes it a positive 6. That makes this a positive 1, which gives me a 6. Now that's going to make more sense to me, which is still positive, but I didn't think it should be in that area of the graph that I had it in. Alright, so let me erase that point, and now let's go up to 6. So 1, 2, 3, 4, 5, 6. There we go. So when I go to graph these, I can see here on the left side that I can just kind of connect the dot, and my asymptotes are going to shape it. Now the right side, I only have that one dot, but that tells me it's going to be up in that little kind of quadrant that it makes up there with the asymptotes. And so I know that as it goes to the left, that vertical asymptote is going to force it to go up, and as it goes to the right, it's going to keep dropping, but that horizontal asymptote is going to make it turn. Alright, let's see, what else did it say? I think that was it. It's plot at least one point, and then use it. Okay, so this thing paused itself. So anyways, I think we've covered all the steps there, and so there is my graph of this rational function.